Okay, let's review where we were. We're going to make this fishing derby application, and we started out with the smallest thing that was possible, which was a fish. So a fish for our purposes really just has a weight, and we threw in type just so that we can try to describe the fish. So that's going to be salmon, carp, tuna, whatever it happens to be. And then we said, next level up, we're going to have to put fish into a bucket, and each bucket is going to have the first name and last name of whoever owns that bucket on it. And in addition, there's going to be a list of all of the fish. So the list is going to keep the fish for us. We initialized all the variables. The one that people often forget in their code is to do that initialization for the array list. And if you don't do that, you'll get null pointer exceptions in your code when you try to use it. And we wrote a couple of getters for it. So we're really missing the ability at this point to put things into the bucket and retrieve things. And then we started to write the derby class, and fishing derby is going to have the name of the derby along with all of the buckets for all of the fisher people. Okay. And a getter for each one. And we started on the idea that when people come and register for the derby, they bring their own bucket to us, and we take that bucket and basically put it behind the scenes into a list so that we're holding on to all of the buckets. So the derby or the registration class is the one that's holding on to all of the buckets. And then the next level up at the top level, we've got the driver program, and the driver program starts out by making the derby itself, planting the flag that says there's the title of our derby, and then we're going to proceed to register people. So in order to register people, somebody comes along and makes their bucket, and then they hand over that bucket to the registration desk. Okay? And this was the one where we had the choice. We could have made the new buckets inside of registration, but we chose to make them bring their bucket, so the new, that's why the new is outside of the registration class. So they wander up with their bucket's already got their first and last name scrawled on it, and they hand over that bucket. Okay? And then registration is going to hide that bucket on the list someplace. Okay? That's where we are so far. Notice I said the other day that in Java and a lot of these object-oriented languages, anytime you use a noun for a thing, that automatically means let's create a class. Okay? So we've got three things. We've got fish, buckets, and this idea of a derby or a registration desk, and then we've got a driver program that's in charge of making them all work together. Okay? And this driver program is more like a running commentary on what's happening through the day. We're eventually going to change out this text-based driver program, and I'll show you a GUI-based program that's laid over top of all of the other classes in order to actually get a functional program like we would use in a sort of modern world. Okay, so for now we're just going to make all the test data ourselves. So we're going to register a few people. So let's just make another person here. So we'll make a bucket for Barney. The short way of doing things, by the way, is to not bother with the variable and just stuff that thing right in there. So we'll make a new bucket with Barney Rubble. If anybody ever sees these on YouTube, somebody's going to come along and report me to the Flintstones people and make me pay money. Okay, so there's Barney Rubble added, and we'll add in somebody else. Oops, wrong thing. We'll add in Wilma. I want people specifically with first and last names that are a little bit similar. Okay, so there's all the people that are registering. Okay, so registration is complete. The horn sounds. It's time for people to go fishing. Somebody catches a fish. So first we need to create a fish. And we'll say that it's a 20-pound tuna, really small one. Okay, so there's the fish, comes out of the ocean. And somebody brings that fish up to the registration desk. What are they going to say to the registration desk? They're going to say add, essentially. We used register, so add is okay. I'm going to call it add fish, just so they know what it is. And they're going to supply their fish. And what else are they going to give? Who caught the fish? Right, so they're going to walk up to the registration desk and they're going to say, I'm Fred Flintstone and here's the big fish I just caught. This needs to go into my bucket. Okay, so the information that we need is, here's the fish, and how do I find the bucket? So what's the sneaky thing to do here? Well, the choices are, you know, like I could supply the names Fred Flintstone, but if I supply the names Fred Flintstone, I'm presuming that somebody's smart enough to look up Fred Flintstone on a bucket and be able to figure out what that means, okay? So what's the simpler way to get people to know what bucket to put things into? Talked about this approach the other day. Suppose the buckets were, the names were scrawled in Korean. And you were in charge of trying to put stuff in the buckets. What would you get people to do to help you when they arrived with their fish? They can't go behind the registration desk. It's only you who's charged with this task. You could make a registration form, but even better yet, get them to bring the fish and a bucket that looks like the one I'm supposed to find. So if they were to bring a bucket that looks like the one I'm trying to match against, I don't really care sort of what's scrawled on it, as long as it looks like the same bucket as the one that's in the lineup someplace, then I know that that's the appropriate bucket to put the fish in. Okay? So this is this game of what we'll do is we'll get them to bring, rather than saying words to me which are probably totally meaningless for registration if it's in some foreign language, it's like, why don't you just bring me a bucket that looks like the one where you want me to put the fish in? Okay? So they've got a matching bucket, so we'll do it this way. And we'll make another bucket that looks like the one that we want to find. And then when we ask them to put something into the, go put the fish in the appropriate place, we'll say, well, this is easy. Here's a bucket that looks like the one. that I want you to put that fish into. Okay? Which means that registrations add fish takes a fish and a bucket. So we'll go into the Derby class and we'll write, oops. Do it again. Public void add fish, and add fish takes a fish and some generic bucket. How about that? Match this one. Okay, so now I'm playing the role of I'm behind the registration desk, I'm standing there with a fish and the bucket I'm supposed to match. What do I do? Where am I storing all of the other buckets? In all buckets. So all buckets is holding on to the real buckets where I'm supposed to put fish. And what I've got in my hand is a matching bucket to the one that looks like the one that's already in the list. So I've got to go through all of the existing buckets to see whether or not I can locate the matching bucket one at a time. Okay, so I could write a for each to do that, but there's a shortcut to do that. What's the shortcut? There's something that already does the work for us. And it's something that the array list owns. Anything there that looks familiar? Index of is search for. Okay, so index of will do the job of searching for a matching bucket. So all that you have to do for index of is you supply the match this one, and index of will locate it for you. What does index of give you back when it finds it? An integer of where it is and so then we can talk to all buckets again and we can say go get the thing at that position, and we'll just assume that it's on the list, and what we get back is the actual bucket or the found one. Okay, so that's the one that looked like the one we want. We go find the one on the list that matches that one, get the actual bucket, and then what do you do? Add the fish to the bucket, so that's actual bucket dot, oops, no add, but that's because we haven't written it yet. So now we know that the bucket class needs to be able to add a fish, which isn't a surprise because we've got no way of getting stuff onto the list otherwise. So we'll go into the bucket class and we'll write public void add that takes a fish and it's just going to dump the fish into the bucket. So all fish dot add a fish. So get the list to remember all of the fish. Okay, so this is add for bucket that just calls add for the array list to hold on to all of the fish that we've got. life seems good, but there's a problem with this. This should work, but there's going to be a problem on this line. What does index of use in order to match a bucket against a bucket?
Equals.
Yeah, equals. Index of has no way of knowing how to do the match, so it assumes that you're going to have a method in the fish class, or sorry, in the bucket class, that's going to be in charge of matching buckets. Okay, so a bucket needs the matching function, which returns a Boolean. And it takes, another bucket. It's really easy to tell what it takes. If I'm in the bucket class, I need to match against another bucket. How does that look? I'll just return true, must be a match, just to get the syntax error out. Is that the standard equals method? When in doubt, put @override over the top, which says I'm planning on writing a standard one, and it says, nope, not the standard. So that's not the standard because equals can, well, we're just talking about this line. The rule for equals is that you can match against anything, not necessarily just other buckets. And so this thing actually actually insists on taking an object to match against. But we know that we'd better be matching against another bucket. So we're going to say that thing that you gave us is really a bucket, damn it. Now, if it's not a bucket, if it's something else, this line will die. And that's a really appropriate thing to do because chances are pretty good you didn't intend to match a cat against a bucket. Okay, so now we've got the other bucket. What would say it wasn't a match? We've already got, oh, it must be a match as the easy case. If the names were different, so if the last names aren't the same, so if the last names were the same, that would be last name dot equals other dot last name. And if they're not equals, you can just put the not on the front. And so if the last names aren't the same, then the answer is they're not the same person. And we'll do the same thing for first names. If the first names aren't the same, they're not the same person. Okay, and notice that because it's another bucket, I can use that variable directly for the other guy. I don't have to call this getter. That's that special professional courtesy rule in action. Okay, so the bottom line of this is that index of is search for, and in order to decide whether things match or not, index of is going to make use of the equals class that's written in the things that you're trying to match against. So you better have written this, otherwise you're not going to find a match. Okay? The other way of thinking it is, as a matter of course, you just turn around and write an equals all the time for your methods, and that makes sure that if anybody wants to use that class in the future, it's automatically going to match against something that's appropriate. Okay? So now we can see whether or not a bucket matches, and that's all there is to it. Just go find the matching bucket from behind the scenes and dump the fish into the bucket for the person that it belongs to. Okay, so back to the driver. We've now got the ability to add a bunch of fish, and what we'll do here is we'll just hand over a bunch of fish to a bunch of people. So now that you've seen one of them, I'm just going to do a bunch of them here. And I'm going to do add fish, and in this case I'm just going to do that work right inside there, and for the matching bucket I'm just going to use that information now that you've seen it once. And we'll say that Barney catches a bigger tuna and then we'll make a couple for Fred. And we'll make sure that Wilma gets at least one fish. Now it's a good idea when you're doing your first test data to make sure that everybody gets at least something. That'll just prevent any weird sorts of errors about somebody not having anything and trying to match against them. And we'll just change some of these numbers. We'll put in 15, 10, and 40, and I'm just going to even mix them up a little bit so that they're not in an obvious order. Okay, so I've just tried to mix up the people, and they're in a different order than they first went into the buckets and all of that sort of stuff so that they look a little bit different. Okay, and just for fun, no reason at all why you shouldn't run the debugger. And do one more step over just so that we get all the fish added. And then out of interest's sake, we'll go take a look and see what we've got. So if we crack open the registration desk object, there's the registration desk with the name in it. And there's our array list that has all buckets. Now you don't actually know very much about array list. You've never seen the code before. But oh look, I can see that there's a size variable that says that there's 3 things on the list. If I crack open the list, there's my 3 buckets. If I crack open a bucket, there's Fred Flintstone's bucket with an array list of the fish inside, and it looks like he's got 2 fish, and we can go see what fish are there. He's got a 15-pound tuna, and he's got a 10-pound tuna. Okay, and if I go back and look at my code, I gave Fred a 15-pound tuna and a 10-pound tuna, and so I'm pretty sure that somehow add is doing the job and I'm getting fish in there. Okay, so the debugger is your friend, and you can look at things even if they're not necessarily things you've written. You can guess at how those other classes work sometimes. Okay, so people have caught their fish. Now what happens in the fishing derby? Next step, the horn sounds. The derby's over. What do you want to know? It's the first thing everybody wants to know. Who caught the biggest fish? And show me this monster fish. Right? So everybody comes up to the registration desk. And they're going to ask a question. Who's the winner? And what comes back? I want the thing here, right? I mean, people are asking for the thing. If you give the biggest fish, I would have called it get biggest fish, and then we wouldn't have known which fish, like who it was, right? And so the important thing at this point is who's the winner, and the winner is actually the winning what? Well, it's not the name, it's not the biggest fish, but it's the bucket with the biggest fish, because that has the name on it and the fish. Okay? So there's, again, this idea that you're used to in other programming classes. They keep wanting you to extract this one piece of data that you need. In the sort of the object-oriented world, when somebody asks a question, you give back the thing, okay, the entire thing at once, because if I've got the bucket, it's got the name, the first name and last name on it, and it's also got the biggest fish in it someplace. Okay, so I can ask questions of the bucket. I can say, hey, what's your first name? What's your last name? What's the fish? I can do I've got all of the stuff I need if I have the bucket in my hand. And if you just give me back one piece of information, oh, here's the last name, then I have to go ask again, or I have to get it in 3 different pieces, right? Okay, so the thing that's important that comes back here is the bucket of the winner. Because then I can always go say bucket.get first name, bucket.get last name, bucket.give me your biggest fish, as long as I've got the bucket in hand. Okay, so literally somebody just drags the winning bucket out to the front of the registration desk where everybody can look at it. Okay. Okay, so that means that the Derby class needs to have a get biggest or get winner Now's where the fun starts. Who won? If this were a math class, and I said, give me a math function or a spreadsheet function that describes what I want here, all I want is the best fisherman, which is really the biggest bucket, which happens to contain the biggest fish. Okay? But if I get the best bucket that I can possibly get, I've got what I want, right? Okay, so let's just do that. If I say bucket best bucket is what? Biggest. What's the spreadsheet function for biggest? Or the math function for biggest? Max, min. So max gives you the biggest of all of the buckets. That's what you'd like to write, but that maximum function has to come from someplace. What's the thing that has a maximum function? That collections beastie that we looked at the other day has the maximum. Okay, so we'll just click on the yellow bulb to get the import statement. So it's really easy. It's just all I need is the biggest bucket. Except, not yet. I mean, someplace we're going to get to a level of detail where somebody has to compare things, but for now I don't care. All I need is the biggest bucket. Okay, so biggest or best, right? That's all that maximum does. Except that the complaint here says you can't use maximum because what's missing? You don't know how to compare buckets. And the thing that's missing is that bucket needs to have something in it, this comparable idea that says that it's possible to somehow weigh one bucket against the other. And maximum can't figure that out by itself any more than searching for could figure out how to match two things unless you write that function to tell it. So in this case, the bucket class is missing the ability to compare ones with each other. So we'll say, oh, okay, it's got that ability someplace in it. So we'll write implements comparable for another bucket. And as soon as you say it's got that capability, Eclipse says, no it doesn't, unless we write it. So we'll add the missing method, usually plops them down at the bottom, and the method that's missing is to be able to compare yourself to another bucket. So it's this bucket compared to some other bucket that somebody gives me. Okay, so now we have to figure out how to compare buckets. So this is one bucket compared to another bucket. How do I decide which bucket is better? Whichever has the largest fish in it is the one that's the best bucket. Okay, well, I'll talk to, if I were to go grab a fish that was my biggest fish, that would be, talk to the, it would have to come from all fish, which is the bucket, which is the list that's holding on to the fish. How would I get the best of the fish? How did I get the best of the buckets? Same way, right? So this collections.max says find me the best of the buckets. So if I want the best of the fish, I'll call collections.max to say find me the best of all of the fish. Except collections.max here says that nasty error message again because the thing that you're trying to compare is one fish against another fish to find out which one is better. And it's saying fish don't have the ability to compare themselves to say who's bigger. Well, if we go look at the fish class, that's true. There's nothing in fish that describes how to compare one fish to another. So we'll say, okay, we'll provide that facility so that you can compare one fish to another. Okay. And same thing there, as with the Derby class, or it's going to warn and it's going to say you haven't written that. So we'll write that in fish also because we need to weigh fish against each other. So now we've got one fish compared to another fish. So how do two fish decide which one is better? What makes one fish bigger than another in this case? Their weight. So if I take my weight minus your weight, if I'm bigger, I'm plus so many pounds. So this one is actually really easy. As soon as you've got an integer, it's just my weight, which is the current fish, against the weight of the other fish. Just take the difference in their weights. And so if I'm a 20-pound fish and you're a 5-pound fish, it's plus 15 in my favor.
So basically you have to compare buckets and then compare fishes inside buckets?
You have to compare buckets, needs its comparison, because it's really just weigh one bucket against each other, right? Which could be by the way, it could be just by total fish weight, right? Would be another way of saying you're a better fisherman. But in this case, we've said it's not by the total weight of the bucket, which would be add up all the weights of all the fishes. But in this case, we're saying that for buckets, it's just solely which fish in the bucket is bigger than somebody else's biggest fish. Okay? So buckets are compared by biggest fish, but fish are compared by the weight of each individual fish to determine who's bigger. Okay? So the bottom line of this, to work backwards, is to say if for some reason you think that the class that you write is going to need to be weighed against something similar, then you have to provide a compare to that does the standard form of weighing. Okay? So in this case, we decided that for our purposes, for this program, the standard form of comparing one fish to each other is by their weight. It could have been by their length, it could have been by some other combination of things, but for this application, it seems like the appropriate thing to do is to compare them by weight. Okay? So fish are compared by weight, and buckets are compared by the largest fish within the bucket. Okay? So, working our way back up again, we've got fish taken care of. And if we move back up and we talk about bucket, we got to the point in bucket where we've got my biggest fish. So if we're comparing a bucket against bucket, what's the other piece of information we need? Their biggest fish. So fish, your biggest fish, is the biggest of the fish, so that's biggest is now collections.max, get me the biggest, and in this case, it's the other guy's list of fish. And again, I don't have to call, I could call his get biggest fish or something if I wanted to, but that'll work. Okay? So, I'm now holding on to my fish, my biggest fish, and your biggest fish. How do I decide whether I'm bigger than you are? You said subtract the weight from each other, but that would mean that I would presume that I know something about how fish compare each other. Introduce the two fish to each other and let them decide who's bigger. So the difference between the fish is my biggest fish compared to your biggest fish. And we'll just return the difference. Okay, so remember we said that compare to for fish took care of taking the difference in their weight. So I don't have to see it, but what's going to come back there is a number that's actually the difference in their weight, and then we'll just send back that difference. So if it's a positive difference, then that means my fish is bigger. If it's a negative difference, that means your fish is bigger. Okay? So I put this in a variable just so that you could see it. You could, if you wanted, put that thing directly in there and not bother with the variable, but it's just easier to leave it there so that you know what it is and so that the debugger can help you look at it if you want to look at it. Okay? So that's all there is to it. I mean, this is exactly what we said when we talked about it in English, right? You step up to the first guy who's standing in front of his bucket and you say, hey, get me your biggest fish. You walk up to the second guy on the list and you say, hey, get me your biggest fish. And now you're left with the problem of figuring out which fish is bigger. So in this case, one of the fishermen just introduces the two fish to each other and says, hey, which one of you two is bigger? And he passes that word along. Okay, and we'll go into the Derby class. So there's the best bucket is just the biggest, and so we'll send back best bucket, which is just go find me the biggest one. Okay. And if we go back to our driver class at this point, we've now got, if I spelled registration desk correctly, then what I get is the winner. So let's just print out the winner. So I'll get the first name of the winner. Dig out the last name. Okay, so there's who won. What if I want to print out information about the fish that won? Where's the fish hiding? Who's holding on to the fish? What variable?
The matching bucket?
This is the winning bucket. So I printed out the name that was on the winning bucket. Where's the fish hiding for the winner? It's in the bucket that I just dragged forward, right? So someplace in that bucket. So after I've gotten the information that was on the front of the bucket, I'm going to go call winner.getBiggestFish and have him dig in the bucket for me because I don't feel like doing it. And what he'll produce for me is the biggest fish. Okay, which means that we have to go into the bucket class and write something that gives the biggest fish How do you get the biggest fish? Take a look immediately below. There's the thing right there that gets the biggest fish out of just this bucket. So it's just the largest fish that's in the bucket. Okay, you could fix this now, and you could, instead of calling, you could make this say my biggest fish is get biggest fish if you wanted, if you didn't want collections.max to repeat. But now, having done that, we can now get the biggest fish, and if we do another print statement, biggest dot get weight plus my insert key biggest dot get type save that. So I printed out hopefully the biggest fish and weight, and we'll just run this thing and see what happens. And it said the winner is Wilma Flintstone with a 40-pound tuna. And if we take a look in all of the stuff that we put in, there's the 40-pound tuna from Wilma. Just to verify that it works, we'll change that to a 55-pound tuna for Fred, run the thing again, and now there's the winner. Okay? So at this point, very quickly, we've now got something that will at least allow us to run the Derby. It's not the prettiest of things yet, and we're missing some things. I can print out the winner, but now what I want afterwards is a list of all of the fish in order of winning fish, or sorry, winning fishermen, right? So who came in first, second, third, fourth, and I also want an alphabetical list of all the fishermen along with their biggest fish. So that's what we'll do tomorrow to finish it off, and then I'll show you a GUI on the front of it that makes it all look nice and pretty.